Hi everyone. In this tutorial I'm going to teach you how to make your first material, using the best workflow, which will save you time. The first and most important step is simply to organize yourself properly by creating different folders for different types of files. This will allow you to work faster and avoid searching for what you want for too long. To create your first material, just right-click in the content browser and choose Material. When I name my material, I respect a naming convention in order to better organize and reduce the number of characters of the name because you have a limit of the asset file path length. Materials named with M_, textures with T_, and so on. To import your textures, you just have to select them and drag and drop them in the content browser. So back to the material we created earlier. To create a texture sample that will allow us to use the textures, you can press the T key and left-click, or right-click and search for texture sample and select it. Then you can search and select your texture. Or you can select your textures, then drag and drop them into the material graph. You can connect the textures to the corresponding output of the material, for grayscale textures like ambient occlusion, roughness, height, metallic. You can either connect using the RGB channels or only one channel. I recommend you to use only one channel to avoid conflicts when you create more complex materials. To visualize our material, you can use a mesh like the plane in the tab Place Actors and Category Shapes, or use your mesh if you already have one. To be able to use the future parameters of the material we are going to create, we need to create a material instance of this material. This allows to create several variants of this material and to use different parameters in each material instance. To create a material instance, you can right-click on the material and select Create Material Instance. You can also create a material instance with right-click in the content browser, go to Material and select Material Instance. Material instance is called MI_. Open the material instance and select the parent. To apply the material instance to the mesh, just drag and drop the material instance on the mesh. Now we have our material in the scene, but the aspect is bad because the material is not configured correctly. The first strange result is that it has no ambient occlusion, because when you connect the ambient occlusion to the output of the material, you will not see any difference simply because the ambient occlusion is ignored when using the dynamic lighting as indicated in the documentation. To be able to use the ambient occlusion, we can create a fake one by multiplying it with the albedo. To create a multiply, hold down the M key and press left-click or right-click and type multiply, then select it. The result is now already better, as you can see, before, after. Make sure your texture sample of the normal map is set to normal. Usually Unreal Engine does this automatically when importing textures. The normal texture must also have the compression set to normal map. The type of texture compression and the configuration of the texture samples are related. If one or the other is not configured correctly, it will create errors. We will talk more in detail about texture compression in the texture samples in a future video. To be able to change the scale of your material, we need to create a node texture coordinates. As usual, right-click and find the node. Then we multiply it by the scale we want. To create a parameter usable in a material instance, hold S and left-click or search constant, then right-click and convert to parameter. Set the default value of 1. You can create categories of parameters. This allows to organize different groups of parameters that you want to define. Then connect the multiply node to the UV input of all texture samples. Now you can control the scale of the material just by adjusting the value of the parameter, but you can do it directly in the material instance without going into the material graph. To change the value of a parameter, you must first check the box next to the parameter name and then adjust the value or enable it if it's a switch. As you can see, you can adjust the scale of this material. We will now go ahead and create our first material function. A material function is a node containing a group of nodes that we have configured to be reused several times in different materials and even in other material functions without having to recreate it from scratch. This is necessary to save time and make easier the process of creating materials. The final aspect of our material is not finished yet. We still have to solve one last problem. If you move the directional light by holding Ctrl L and moving the mouse so that the sun is low in the sky, you will see that the material reflects too much light. This is because of the specular. The default value of the specular in the material output is 0.5, which is an incorrect value, so we will create our first material function for the specular. To create a material function, you have to search for material function call. You can also hold F and left-click to create a node material function. Then you can select it and choose the material function you want to use. For the moment there is not the one we want because we have to create it. To create a material function, create a functions folder in the material folder, then right-click, material and select material function. Material function is named mf_. In this case we will name it mf_IOR specular. To be able to adjust the nodes from the outside of the material function, we will add a node input. Then we set the input in scalar. The scalar corresponds to the constant, so only one value can be passed. The constants are similar to the channels. You can use up to 4 constants, also called vector 4. The specular value is controlled in IOR, which means index of refraction. Set the default value to 1.5, the most used value for most materials. To make the node input use a default value, connect a constant in preview of the node input and check the box use preview value as default. We can then save and return to our material graph to select our new function that we have just created. In order to use the IOR value with the specular, you have to convert the IOR value because it goes from 1 to 5 while the specular value goes from 0 to 1. You can get most of the IOR values on the Pixel and Poly website, the link is in description. Back in our material function, we need to create clamp and set the min value to 1 and the max value to 5. We need the subtract and multiply nodes. Then create an add node, which you can do by holding A and left-click or searching for add. Then create a divide node, which you can do by holding D and left-click or searching for divide. You can add a description to a node input to remind you what the parameter can do. Now we have a correct specular value which is controlled in IOR. Note that the IOR value is a value to have a correct PBR material. You can however not respect the PBR and change the value if you have a better result. For example, in Unreal Engine I prefer the result of water when the IOR value is 2 while the correct IOR value of water is 1.333. For comparison, here is the result with the incorrect specular. And now with the correct specular. We now have the material aspect which is PBR. We will create the rest of the basic parameters that will allow us to control the look of the material. You can visualize the different texture maps of the materials by going to buffer visualization. So we can add a parameter to control the intensity of roughness. Set the default value for roughness intensity to 1. I forgot to put the parameter for the specular, so I convert the constant of the IOR specular into a parameter. To avoid having values greater than 1 or less than 0, we put a saturate node which acts like a clamp but is more cheap. We will now create a level function, which will allow us to adjust the intensity of white and black. We need a multiply to control the intensity of the white, and a power to control the intensity of the black. To create a power, you can hold E and left click or search for it. And we add a saturate at the end to avoid having incorrect values. When you create a material function, the inputs are in a random order that you may not want. To organize the order of the inputs, you can set the sort priority to each input. Small tip to make easier the organization of the sort priority: do not organize from 1 to 1, in other words 1, 2, 3, but from 10 to 10, for example, 0, 10, 20, 30. It will allow you to add inputs if you want to update your material function. Otherwise, you won't be able to place the order of the input you want. For example, adding an input between 2 and 3 is impossible, and you will be forced to redo the sort priority of all your inputs. Whereas if you add an input between 10 and 20, you only need to set it to 11. We will create the ambient occlusion intensity function using the level function we just created. We use a clamp like in the previous function specular to limit the maximum value of the ambient occlusion intensity. To organize your material graph, you can use reroute nodes to place the links the way you want. To create a reroute node, you just have to double-click on the link. You also have the possibility to add a description to the reroute node. We will put the nodes of the roughness intensity in a material function. Anything you create that may be useful to be able to reuse in other materials or functions, it's then recommended to integrate them in a material function. Now we will create the material function to control the color, luminosity and saturation of the albedo. But before continuing, if you just want to create triple equality environments without having to create your own materials from scratch, you can take a look to my product Advanced Master Material for Props, which represents 11 months of full-time work. It allows you to create 90% of your environments with just this material. It's the master material with the most features available on the market, which was selected by Epic Games to be in the Marketplace Showcase and by Flipped Normals to be in the staff picks. If you are interested, the product is available for UE5.1, UE5.0 and UE4.27. The links of the product and of the video of the features are in the description. Back to the creation of the function albedo color correction. To modify the color of the albedo, simply multiply the color with the albedo. To control the saturation, you need to use the desaturation and 1- node. To create the 1- node, you can hold O and left click. I forgot to put the input color correction in vector 3, otherwise we can't change the color with scalar. The problem with adding features to the material is that it can quickly increase the number of instructions and therefore the shader complexity. The more complex your material is, the less optimized it is. We will talk more about the number of instructions and shader complexity in a future video. To reduce the complexity, we just need to add a Boolean parameter and a switch. This will allow us to disable the features we don't need. As you can see, when the material function is disabled, it reduces the number of instructions. To enable or disable the function, we need the node static bool parameter. So we can control the shader complexity of each material instance by choosing the number of features we want to enable. Now we will add a switch to each material function as we did before to have a total control of each feature in the shader complexity. We are almost at the end. We just have to create the function to control the intensity of the normal map. This is a good technique to control the intensity of the normal map. However, it is possible to lose some information in the normal because we only use the R and G channels. In a future video I will explain a technique that allows to recreate the z-axis of the normal, so the B channel. To split the channels, we need the node component mask. Leave it by default because it already has the R and G channels enabled. The others must remain unchecked because we don't want them. Then with the append node to convert to normal. We control the intensity with the multiply node. We add the node normalize, which allows to normalize the normal map to avoid bad values. Now that all the material functions are finished, I organize the sort priority and the group of each parameter. We now have full control of the look of the material, however we have one last thing to do: convert our texture samples into parameters to be able to use different textures. To convert texture samples into parameters, just right-click and select Convert to Parameter. You can now put different textures for each material instance. You can also choose your default texture. For example, in my master material I use a grid texture of 2 meters by default. You just have to select the texture you want to display by default. Now that we have finished creating our material, every time you need a new material, you just have to create a material instance. Thanks for watching. Leave a like if it was helpful and subscribe to be notified of the future videos.